Chapter 21, Symmetry and Transformation. In this chapter, you will learn how to identify all the symmetries of 2D shapes, and also you will learn how to transform 2D shapes by rotation, reflection, translation, and simple combinations of this transformation. So let's take a look at what does it mean by a few terms. So line of symmetry is a line where it folds the shape into half exactly. As for order of rotational symmetry, it is number of times a shape fits into its outline in a full turn. So here, you're going to learn how to identify the lines of symmetry and rotational symmetry. Let's take these four shapes for example. For each shape, state the number of lines of symmetry and state the order of rotational symmetry. So as mentioned before, the lines of symmetry is the line where you fold, you will get exactly in half. But here they were asking you how many number of lines of symmetry, meaning how many times you can fold that you get it exactly half. If we take this hexagon for example, since it has 6 sides, and inside here there is a 6-sided star. So you can actually imagine this can actually be folded into half if there is a line here. It can also be exactly folded into half if there is a line here, in which when you fold, you will get a half. But if you cannot visualize, what you can do is use a pencil and a tracing paper okay, lightly trace the shape. Okay, so let's take this shape right now, okay, and to determine our line of symmetry. Just like the definition of line of symmetry, there is a line where you can fold it into exactly half. So if this one is folded onto here, you can actually see it is roughly half of the shape. So this is my first line of symmetry. Next, I can fold it like this to roughly get the second line of symmetry because it gets exactly half. This is my second line of symmetry. So there are actually two more lines of symmetry. If you can see, we can also fold it like this. To get exactly half. As you can see, you can also fold it into this half to get another line of symmetry, and also this half to get another line of symmetry. And you can actually try to compare with your original shape. And finally, you can actually try to compare with your shape to see how many lines of symmetry are there. So if you were to fold this shape along this line, you can get exactly half. If you repeat it over this line, you can also get exactly half. This half is mirrored to this half. You can do the same on this line, where this half is the same as this half. Similar to this, if you fold along this line, you will get this half to be the mirror of this half. Same goes to this line. And we still have one more, which is the line across here. We have identified all of the lines of symmetry for this shape. So let's count how many lines of symmetry we have here. 1, 2, 3, 4, 5, 6. So over here, the number of lines of symmetry is 6. Okay? How about the order of rotational symmetry? So you're going to use the tracing paper to sketch again on the same shape. Roughly sketch is sufficient, you do not need to be accurate. So what you need to do is to label the top on your tracing paper. And next, you're going to try to rotate it. So if you were to rotate it, okay, you can actually see the outline fits into the shape for the first time. And then if we were to rotate again, it actually fits for the second time. And you have to repeat this until you get one full turn. Okay, if you were to rotate again, you're getting a third, fourth, fifth, and finally in one full turn. So it has repeated 6 times. In other words, the order of rotational symmetry for this shape is 6. Let's take a look at this shape. How many lines of symmetry that it has, and also how many order of rotational symmetry does it has? So again, number of lines of symmetry is we see how many lines that it can fold to get an exactly half. So if we were to fold it this way, you can get the mirrored half of it. But if we were to fold any other way, if it's here, or it's here, or here, we cannot get an exactly half. So number of lines of symmetry here is 1. As for order of rotational symmetry, you're going to do the same thing by using a tracing paper. Roughly trace out the outline of the shape. And let's rotate for a full turn. So if we were to rotate it in a full turn, it only seems to get, the outline only repeats to itself 1 time. In other words, since it's only have 1 repetition, the order of rotational symmetry is 0. So take note, if a shape rotates in a full turn and only has 1 repetition, the order of rotational symmetry is 0. So for this shape, you can actually try to find the number of lines of symmetry. So if I were to fold this into half, although it gets a similar shape of half, however it does not mirror. So this is not the line of symmetry. So let's take the tracing paper and roughly draw the outline. So if I were to fold this into half, you can actually see it no longer fits the shape as how it is over here. So this is not the line of symmetry for this shape. However, we can actually fold it across the diagonal. So if I were to fold across the diagonal, I do get a symmetrical shape, just like the other half. So this is my line of symmetry. Now let's try if I were to fold it across this line. Now take a look here. If I were to fold it, my mirrored shape appears to be like this. However, it does not fit with the original shape. Hence, this line is not my line of symmetry. Finally, we can actually try to fold it in this direction. We can actually try to fold it in this direction. So here, we can see the shape is as mirrored as this shape. Hence, we have another line of symmetry over here. In other words, the lines of symmetry that we have here is 2. How about rotational symmetry? We're going to do the same thing. We label here as our top. And we're going to try to rotate it and see how many times that the outline repeats. So let's rotate. Okay. Nothing yet. It doesn't repeat yet. It doesn't repeat yet. So here it repeats once. And let's go into full turn. And here it repeats twice. So here it has the order of rotational symmetry of 2. For this shape, you're gonna have to try it yourself. So over here, you're gonna encounter questions that has boxes that has shaded for you, and you're gonna shade a few more squares so that it can get the rotational symmetry as it is asked for. For example, over here, shade 4 more squares so that the shape has order of rotational symmetry 4. As intended here, for an order of rotational symmetry 4, you will have to rotate it in a full circle where the shape to have 4 exact same outline. Now, if it's just looking at like this, it is a little bit difficult to identify which 4. So for this question, you'll have to use a tracing paper. So the technique here is you just need to roughly sketch the outline of the shape and the boxes that can be shaded. Okay, so as before, you're going to label your top side of the shape, and for this time, let us try to mark which one has been shaded. So this part has been shaded. Now since it wants a rotational symmetry of 4, in other words, if you were to rotate it in a full circle, the shape needs to repeat 4 times. In this case, you're going to shade 4 more squares. So we are going to try to find the 4 more squares. So if I were to rotate, it should have a similar shape from this when the top is at the right, and when the top is at the bottom, it should have repeated for another shape. And if I were to rotate it to the top is at the right hand side, it should have another similar shape, and it goes into a full turn. It should repeat 4 times. The technique here is, as intended, if you were to rotate it for the first time, we'll notice that there are a few boxes that are not shaded yet. For example, this part right here, and also this part right here, and also this part right here. So let's mark it down first. So these 3 boxes are our new boxes that have not been shaded. So 1, 2, and 3. Okay. Now if we were to rotate again, we do get the same outline as the original side. And if we were to rotate again, we do get the same original outline. And when it goes into one full circle, it does get into the original outline. Which square that we need to shade right now, if we go to compare the original shape and the one that we sketch? So it seems like here we need to shade this part, and we also need to shade this part right here, and we also need to shade this part right here. Now, if we were to look in the question again, shade 4 more squares. If we were to shade here, here, and here, it is only 3. But for us to get a rotational symmetry of 4, the 1 more square that will not affect the other shade would be the one in the middle. So these are the 4 squares that we should shade. And hence, 4 square has been shaded to get a order of rotational symmetry 4. Let's take a look at the next question.